Hey guys, welcome back. So it's time to go ahead and get started on this rotor shaft here. We've got some repairs to make on it. This is for the Kearney and Trecker milling machine. This is out of the electric motor for it. And you may have already seen, if you haven't, you can go back and check the videos out. I've already repaired the two end bells right here. These are the end bells that go on each end of there. We got those done. Both of the fits were loose in the end bells. And since miking the two bearing journals, which is right here and right here, they are both undersized. So I'm going to build them up. I'm going to be using the spray welding technique. That's where we'll undercut them. I'll build them up using the spray weld or metallizing technique and then turn them back to size. It's a technique I like to use because it's simple and it's very effective for applications such as this, is where you have an interference fit over the spray weld. Helps keep it captured in there. So this is my chart. This is one of my charts that I use right here that gives you all of your standard bearing number sizes. And then you have a shaft diameter fit and then a housing fit. This would be the housing fit right here, and then this is the shaft fit. And what it does is it gives you a tolerance. It gives you a plus and a minus, or a low end and a high end, and you got to fall within that range for a proper fit. So we're using a 6207 bearing. So the shaft, it says the shaft seat diameter for this shaft right here, the minimum is going to be 1.3778 inches, and the maximum is going to be 1.3782. All right, so that's really only giving us 4/10 of leeway there to fall within, a window to fall within. All right, so this side right here is definitely worn. It's worn out pretty bad. So getting the mic on it in that particular spot, we're at 1.373 and a half. So 73 and a half, that's 4 thousandths under on that right there. And I mic'd it another spot and it's 5 thousandths under. Now this bearing fit right here is right on the borderline of it being bad, but it is bad. So we're at 1.377 and 1/10 on this side right there. But I did mic it in another spot and it was even lower than that. So both of them are bad. So we're going to go ahead and fix both of them. We'll probably use the Victor lathe. That's where I usually like doing my spraying and machining in here. I've got to, this will be the first time spraying back there where the Victor's at. So I have to get my fume extractor back there to suck up the fumes when I'm doing it, and get the torch back there. It'll be a little bit of a tight fit, but I think I can do it. All right, so I will bring you guys along the way and show you the process, okay? So one of the things that I typically have to deal with whenever I'm doing these rotor shafts is I have to repair the center in the end, because the people that usually take these apart don't ever put anything on the end. They have center savers. It's just a spacer that goes in between the shaft and the puller, so that the puller is not twisted on the shaft center itself. So I have to set this thing up. Now I'll be able to set this in there with a center to hold it, and then get me a steady rest in here adjusted to hold the center, and then we'll have to recut the center so that it's true wherever the steady rest is running. This side over here, the opposite side, I don't know if I'll have to recut that, but we'll have to check it and see. We'll clean this out with some emery paper because it looks like it's got some rust in there. And then stick the center in there and make sure the other side's true, and then indicate it right here and see if it's running true. And if it's running out, then we'll have to set the steady rest here, recut this center as well. Okay, let's go ahead and get this thing set up here. I am going to use the 6-jaw here. I want to see how it's going to do. We'll get her chucked up and then we'll do a indicating test down here and see what kind of run out we get on the end of the shaft. That's just holding it there. We're going to go ahead and get the center in the end. I want to go ahead and tighten up the 6-jaw on this end, and then we'll check it with an indicator. All right, we'll try to get right back here where that fan's going to be spinning, because I know that the bearing journal is a little bit worn, plus we're off center on the other end of the shaft, so I'm trying to get as close to those jaws as I can. Man, look at that. It's flickering a little bit, but I'd say that's 1.5 thousandths. Not bad. Okay. All right, so that end's going to be pretty good. Let's go to the other end and see how far out that center is running on the other end of the shaft. We'll get it real close, and then I'll use my fine adjustment here. We'll just do a light preload. Right about 6 thousandths. So we definitely are off center, and that's from that damaged center right there. I want to go to the inside here and see what kind of run out we're getting up here close to our journal. It should be a good spot right in there. That's about where the fan's going to be. I think that's what these holes are for, is for the fans, because there's one on the other side too on the very end. That's not good. That's looking to me like it could be a bent shaft. I don't like that. Getting about 2 thousandths down there by that journal. I'm going to go ahead and we're going to go ahead and set the steady rest right in here. I'll polish it up, get rid of that rust that's on there, and we'll go ahead and recut the end, and then we'll see what this shaft end's doing right there. This may have been why when I had first shown this, I put an indicator right here on the pulley on the sheave, and it was running out like 15 thousandths, so that might be why. We may have a bent shaft here. You see that bearing area really good now. You can see right there where that bearing was. Come on, pumper. Alright, so the shaft is supported on a good area of the journal there that's not worn, and then we've got our chucked in down there that's running nice and true. And on the very end of the shaft, consider 30 your lowest. So there's 10, 14, nearly 15 thousandths. That's just like I was indicating out on the table with the motor together and the pulley on there. It was measuring about 15 thousandths. So what that's telling me is that the shaft is actually bent. It's bent there at the journal. And I've got a feeling, I have no way to prove this, My suspicion is that this area was welded also. I can see the valleys in there now where somebody had welded it up. They started the bead right there and went around, and then the bead stopped. There was probably the flux there, and they couldn't tie the weld bead in, so there's a valley right there. So that's just telling me that this has been welded up, and this most likely was warped whenever it was welded, and it was put back into service like this. And this run out here is what's causing havoc on this motor, the vibration. So honestly, I don't think that I want to reuse the shaft now because of that. I think it's going to be best to maybe just make a new shaft for this. Press this out, press this shaft out of here. I'll have to get some measurements from this shoulder here to the face of the laminations, you know, make some dimensions there so that when a new shaft is put back in, it's put back in the right place. But I think it's going to be best to, at this point, don't worry about fixing this shaft, press it out, take a new piece of stock 4140 and make a brand new shaft for this thing, and then press it back in there. I think that's what we're going to end up doing. Alright, so what we want to do is press this shaft out that way. I can tell that whenever it was pressed in that way. They've got a little bit of undercut on this side, and there's also a little bit of a weld blob right there, which, I mean, you could grind that off, but I just want to go ahead and push it out that way. So one of the best ways to do that is you have to support it in there on the laminations inside there. And what you can do is find you a piece of tube, which is what I just did. I found this piece right here over on my shelf, and it just about fits in here perfectly. It's hitting part of the aluminum casting in there. There's some little divots in there that this is hitting, so all I got to do is just chuck this up, and we'll just turn the end down a little bit further just to clear those little divots. And then what that'll allow is the laminations to set on this piece right here and be able to press it out. You don't want to set it on this right here and press it, because you'll just mush this away. It's just very soft aluminum. And hopefully it's going to come out okay. I don't know how tight it is. I've had shafts in these rotors that were so tight that I've destroyed one of these before trying to press it out. I mean, it just twisted it. It was so bad. And then we've had some that the shaft had galled coming out. But for the most part, they usually come out pretty good. You have to put some tonnage on it, and that's why we've got that Dake hydraulic press. But we'll give it a shot and see how it goes. So let's modify this, get that to fit in there right, and then we'll go to the press and see if we can press it out. I'm putting just a little bit of this knocker loose around it while I go to modify the other piece, just with hopes that maybe some of this penetrating oil will work its way down in there and help it a little bit as it presses out. All right. See how close we got it by using that method there. We'll put the indicator out there and see how far out it is. A little bit, a few thousandths. Four. Wasn't too far off. I realized, what's the point in bumping that thing around? It's nice and tight on that chuck for just a press plate. We don't need to worry about bumping that thing around. Let's just go with it. We don't need much. Make a couple cuts here. It's probably all it needs. I'm going to go ahead and clean the face up while we're here. That's some more of that stainless. I want to break that edge there. All right. Not that one, it was this one here. There we go. That's going to work real good. So we'll set this on our press plates right there and apply some pressure, and hopefully that shaft will come right on out of there. Okay, I think we're ready to start trying to press this thing. Got everything set up. I've got my table adjusted. We have 2 pins in the table on each side. I got one underneath the channel, and you have a pin that goes right through the center of it as well. So it's double pinned. And I think we're just ready to go. Ready to see what this thing is going to do. You'll have to excuse the noise. I do have the valve on the back side of the air compressor has got a leak, and it's a part that I need to replace that I just haven't got around to fixing it yet. So another project on the list for the shop. It's tight, very tight. The thing is in there. I might have to go the other way. Sometimes when these things are pressed in there, it's got the laminations pushed to one side, and it's hard to get them to reverse the other way. It adds more pressure to it. So I may need to, that was a lot of tonnage right there. I may need to flip it over and try the other side. Went ahead and got that weld ground off that side there. I'm going to raise it up, I hope, another 6 inches. Try to get as tight as I can. Looks like I'm just going to make it. Yep. Try it again. There it goes. I knew y'all were waiting for that. There goes the hammer. Let me just take this stuff off. That's the thing that was always fun about running this press, man, was Dad sitting in the shop watching me out there pumping this thing, waiting for it to go off like a shotgun. He'd be hiding in the shop and I'm out here vulnerable to the elements. It's tight. Once you get it moving, it'll start moving. Another reason why I like having my hearing protection there. All right, now it's starting to move. Oh, man. It's already got me wore out, man. Keep it going. Oh yeah. All right. We're finally on the home stretch now. Now that's the end of the stroke there. I have to reset it. I caught it instead. There it is. Yeah, we had a little galling in there. It looks like the knocker loose penetrated though. It's in there. I can see it all over the shaft. Yeah, we got a little bit of galling. So we'll have to flap the bore of the rotor here out. Doesn't look bad. We'll just have to do some flapping in there. All right. Okay, there's our shaft. And man, I'm happy that thing came out and didn't screw anything up. So there's our rotor. I've got it marked which way the shaft is going, so I put output, you know, down. It's going to be just like this, you know, once it's pressed in there. This is our shaft output side of the shaft itself. So it looks like, as far as material goes, they got that at 1 3/4. So I'll probably have to buy some 2-inch. I'll be looking for some 2-inch 4140. Let's see how long it is. 18 inches long. So 2-inch by 18. And this is a pretty simple shaft to make. So with the exception of this being right at, this might be metric. I'm just scaling it with a, you know, with a caliper here. Yeah, so this is 1 3/4, and then the rest of it's all going to be metric. This end out here looks like 35 millimeter out here on this end. All right, well, I'll bring you back whenever we get ready to start making this shaft. I got to get a piece ordered, get it in here, and then we'll get back on this, okay? Hope you guys enjoyed watching that pressing video.